workshop and share the slides again. Okay. All right. Now it should be good. Okay, so for the people who just joined the workshop, please re-download the newest slides and code from the GitHub. There's some minor change and some update of the links. Okay, then let's start off the data visualization in R. So this slides will go through the general introduction of the data visualization, and I will give introduction to the ggplot2. The key part, as I mentioned, is the concept. So it's the grammar of graphics. So we will go detail to this one and give you some detailed instruction on how to write the code of the ggplot2. And if we have time, we will look at a case study using the NBA data. And then I will introduce some useful packages and extensions for the ggplot2. Okay, then let's look at this first question. It is when and why to visualize the data. That's the first question, right? Because you need to know when and why to use them, then you start to think about using it. So from the beginning of the data analysis, it's always the exploratory data analysis. The visualization is pretty useful because we can use the plot to explore the patterns, the trend, and the distributions of one variable. If you have many variables in your data set, you can explore the association between the variables. And in the statistical analysis, the data visualization is also useful because you can generate some diagnostic plot like the QQ plot or some other plot for to check the assumption of your linear regression, for example. And at the last step of the analysis, you need to report your results and communicate with the non-statisticians, right? So plot is a more clear way of presenting the findings, much better than the tables and numbers. So I will give an example in the later part. And another thing is, if you have a fancy plot, you can attract your audience. And the last things, of course, you can just draw the plots for fun. If you are interested in some sports like basketball, you can download the NBA data from their website and draw some interesting picture by yourself, just for fun. So let's look at an example for fun. Okay, so there are 12 data sets, and we can see the x-axis and the y-axis. There are two variables in each data set, and one is x and one is y, and one is y. So we can draw the scatter plot of the x and y in each data set, and we can see some special patterns in each data set, right? So for example, the circle one looks like a circle, and this one looks like a dinosaur, and this one looks like an X shape, and this one looks like a star. So they have very different patterns, different shape, different distribution of the X and Y. So what do you think if we generate the summary statistics table for the 12 data set? They should be very different, right? But if we look at the summary statistics tables, so there are 12 data sets. This is the mean of X, mean of Y, standard deviation of X, standard deviation of Y, and correlation between X and Y. They're almost the same. Well, mean of Y is almost the same. Actually, for a summary statistics, for a mean and standard deviation and correlation, there's no difference among this 12 data sets. But actually, they are very different. So that's why the summary statistics table is not enough for describing a data set. They couldn't, the summary statistics couldn't describe the distribution. So that's why the statistical plot can contain much more information than a table of summary statistics. And we also need to be careful when we read some descriptive analysis. Sometimes the descriptive statistics couldn't describe a whole picture of the data. Okay, that's why we need the data visualization. And what to plot here? this is the next question, because we need to know what to plot, right? So for example, if you have one variable, you can plot a histogram, you can plot a bar chart, you can plot a density plot. A bar chart, if you have a categorical variable, you need to use a bar chart. If you have a continuous variable, you need to use the histogram or the density plot. If you have two variables, for example, two continuous variable, you can use scatter plot. One continuous, one discrete plot, variable, you can use the box plot or the Wildling plot. And if you have more than two variables, you can introduce another thing in the figure to represent the third variable. For example, color. You can use the color to represent the third variable. So we can use heat map. And in the diagnostic plot, we can use the QQ plot to check normality. So the key part here is we need to think our data and our variables carefully, and then choose the most proper one for your statistical plot. Okay, this is the key part when you draw some plot. So think first and then do it. And then let's look at the data set we will use. The data is from the MBA official website. It's the stats.mba.com. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 columns here. So the first one is the team, just name of the team, the first column. Second column is the season. So there are 4 seasons in the data set from 2015 to 2019. Winning rate was the percentage of games one team won at that season. And PPS here is the average points of that team get in that season. Offensive rate is advanced statistics. It shows how it measures a team's points scored per 100 possession in that season. And the defensive rate is the team allow other teams to get the points allowed for other teams per 100 possessions. So here, one thing I want to mention is that the offensive rate, the higher the better, but the defensive rate, the lower the better, because the lower defensive rate, that means they allow others to get less points per 100 possession in that season. So the defensive rate, the lower the better. Pace is the number of possessions per 48 minutes for a team, and region is the if the team is from east or west, and the ABV is the abbreviation of the team. So for example, Boston Celtics is just BOS. All right, so this is some introduction of the variables in the data set. And from that data, we can generate some plots. So what information we can get from this plot? We can see there are 4 blocks for each season. This is 2015 to 2016 and 2016 to 2017, and similar for this too. And if we read the legend of the plot, we can see winning rate from small to large circle. So the size of the circle represent different winning rate. The larger size of the circle, the higher winning rate. And we can see the region is different color. So the blue is east and the red is west. So different color represent if the team comes from eastern region or western region. And what else we can see? We can see the x-axis is the offensive rate and y-axis is the defensive rate, right? But one thing here, defensive rate is the highest, from the highest defensive rate to the lowest defensive rate. That's because we want to put, we want to see if the team plays better in defense, they may have a higher location in this plot. So that's why the defensive rate is from the highest to the lowest, because the lower defensive rate, that means the better performance on defense. And the offensive rate is from the lowest to the highest. And what else we can know? So there are some labels for some circles. For example, we know which team are the worst team in that season, and we know which teams are the best team in that season. And what else? For example, we can see in the 2015 to 2016 season, actually the best teams are all from West. And if we look at the middle part, also the West team performs better than the Eastern team, right? but it's a little bit different in 2018 to 2019. The Eastern team catch up. And what else we can see? We can see in the 2015 to 2016 season, most of the team are located on the upper part of this plot, right? But in the 2018 to 2019 season, the most teams locate at the right and lower part of the plot, and we know if it's on the right, that means they play better on offense, and if it's lower, that means they play worse on the defense. So that means there's a trend, right? The it's not 4 years ago, it's like 5 years ago, the teams play better in defense, but after time goes by to 2016 to 2018 to 2019 season, the teams play better in offense but play worse in defense. So we can get a lot of information from one plot. That's if you have a good plot. But if you have a bad plot, what can it happen? What can happen? So if you have a bad plot, the bad plot may be hard to read if the labels and legends are not clear, right? And it may also confuse the people if the plot is not well designed. And it may also deliver some misleading information. Sometimes we can do it in purpose, right? For example, in this plot, we can see the scale of x-axis and y-axis are pretty the same, but if they are not the same, for example, each block has different x-axis and y-axis, right? Then the different scales for x-axis and y-axis. Then this pattern, the trend from 2015 to 2016 to 2018 to 2019 cannot be seen because all the circles will be fully distributed on one block. Then we couldn't see this kind of patterns over years. So that's why, as I mentioned, we need to think first and then do it. We need to be careful when we draw some statistical plot using the data set. All right, this is some general introduction of the data visualization. Then let's go to the ggplot part. Okay, here is a histogram example. The left one is generated by the ggplot tool, and the right one is generated by the graphic package, which is the RBasic package. So here the information they have are pretty the same because it's just a histogram for the different region and different season. But if we look at the code, ggplot2 only have 2 lines of code. But the RBasic package, we can see we need to assign the plot, the position of the plot, and then 2 for loops, and then generate a subset of the data, and then draw the plot. It's much more complicated than the ggplot2. That's why I highly recommend it to use the ggplot2, and that's why the ggplot2 is very popular in the data visualization because it's easy to understand, and code is simple than the RBasic plot. Here we can see ggplot data, we know the data, and we know what is the x, and we know what is the plot, and we know what does the plot split it by region and season. So the ggplot2 is easier to read and much simpler. Then let's go to like how to draw a picture by the ggplot2. The key part is the grammar of graphics. Here just another reminder, if for the people who just joined the workshop, please go to the website, the GitHub, and re-download the slides and code. Some things are updated in the newest version. Thank you. Okay, so let's go to the key part of the ggplot, the grammar of graphics. Now, how to understand the grammar of graphics? The basic idea is you have a data and you have a plot, and how you connect the data with the plot and how you draw the plot. So you want to use some part in the ggplot2 to connect the variables to the features of one plot, and you draw the different layers and put them together. So the basic idea is the graph is combination of independent building blocks. So let's look at it in details. The data is very easy to understand. Data is just the data you want to realize. And there is a set of aesthetic mappings. What does aesthetic mappings mean? That means this mapping can map the variables in the data to some attributes in your figure. For example, in the previous figure, you want to draw the offensive rate on the x-axis. That means you want to the aesthetic mappings link the offensive rate to the x-axis in the figure. Okay. Similarly, you can also link the defensive rate in the data to the y-axis in the figure. That is the aesthetic mappings means. All right, and then is the layer made up of the geometric elements and the statistical transformations. But in this workshop, we mainly focus on the geometric objects because easier to read. It's easier to learn and read the code. That is what you really want to visualize that variable. You can use scatter plot, you can use lines, you can use points, you can use polygons, different shapes. That's the geometrics here means. And you can add multiple layers to one plot. That's how we build construct a complicated plot. We just put one layer, second layer, third layer, and to one figure. And then is the scale. Scale, what is scale? Scale map the values in the data space to the values in an static space. For example, we link the region in the data set to the color in the figure. That is one aesthetic mapping. And the scale can control, we have east and west in the region, and we have red and blue in the color. How these two set of things connect with each other, that's how the scale control. Scale can specify you want to link the east to the blue and to link the west to the red. That is what the scale work in the grammar of graphics. And then is the coordinate system. It's just the x1, xy axis. And the facet, this is important. This is I think this is one of the useful feature in the ggplot2. The facet describe how to break up the data into subsets and how to display those subsets as small multiples. And theme, you can use the theme controls the how you want to display the plot. You can change it controls the font size or the background color or legend box. Where do you want to put the legend? How's the label of the legend? Those stuff. So you can change. You can design your own style of plot by changing the theme part. All right, this is a basic introduction of the grammar of graphics. Maybe it's hard to understand at this time, so I will give some examples to help you understand what does it really means. Okay, so this is the start of the plotting a graph. ggplot function is always the first line. Okay, so for example, here P, we assign P as a ggplot figure, and ggplot is always the first line. And we can specify the data and aesthetic mapping in the ggplot functions. For example, here, data equals to the data you want to visualize, and AES means aesthetic mapping. You can map the offensive rate to x-axis and winning rate to y-axis. At this time, you only create a static mapping. So if you show this plot, the R will give you a plain plot with only a static mapping. For example, offensive rate is x-axis and winning rate is the y-axis, and because you didn't add any matrix, you didn't, so there's nothing on this plot. All right, then for the aesthetic mappings, when you specify the aesthetic mapping, we know you need to specify what part of the plot you want to, this is the part of the plot, and this is the variable in the data set. So it can be x is axis, x-axis, y is y-axis, and if you specify color, that means the color of the boundary of something. For example, if you have a bar and you specify the color, that means the boundary of the bar, the color control the color of the boundary of the bar, and the field control the inside of the bar. And the shape, you can specify the shape can be different shape of points, or specify the size, different size of points, and also line type, different types of lines. And there are many other aesthetic mappings that, in the ggplot too. Okay, then let's go to the geometries. So what is geometries? Geometries are the actual graphic elements which is displayed in the plot. So they can visualize the mapping variables from the data. And we use the plus symbol to connect the multiple geometric functions. And actually we also use plus to connect every function in the ggplot code. So for example, the P here is the ggplot function you generate here. ggplot, you specify the aesthetic mappings, x is offensive rate, y is winning rate, and you use plus geom point, then it will draw the point with aesthetic mappings x to the offensive rate and y to the winning rate. And we can also specify the data and the aesthetic mappings in the geom function as well. They don't have to be the same as those in the ggplot function. So for example, here, if we don't have anything in the ggplot function, that's totally fine. We can specify the data here in the geom function, also the aesthetic mappings in the geom function. But if you specify the data and aesthetic mappings in the ggplot function, it will give this kind of settings to every geom functions without special without any specification of the data and aesthetic mappings. But if you put the data and the aesthetic mappings in one geom function, this can only control the setting for this geom function. And this cannot control the settings for other geom functions in this ggplot. Okay. Then it's because we know we have different plots to draw, so we have different geom functions to use. So for example, one continuous variable, this is, you can draw histogram. It's very straightforward, just geom histogram, geom density is the density plot. And if you have two variables, continuous x, continuous y, you can use geom point to draw the scatter plot, geom line to draw the line plot, line chart, although it doesn't make any sense in this data set, but you still can draw it. You can draw the two-dimensional density, and you even can fit a linear model, linear regression in the ggplot too. You can use the geom smooth, and you can specify the formula. I'm sorry, please mute yourself when you because okay, I think now it should be fine. All right, let's continue. You can fit a linear regression here, and then draw the linear trend of this between the offensive rate and the winning rate. Of course, if they play better in the offense, then they should have higher winning rate. Okay, then is if we have a discrete x and continuous y, we can use box plot or Wildling plot. Here, the x-axis is the season. We have 4 seasons, and y-axis is the winning rate. We can see the different distribution of the winning rate in the different season using the Wildling plot, where we can see the 5 numbers the median, first quartile, second quartile, and some outliers. That's also minimum and maximum of the winning rate in each seasons. Okay, as I mentioned before, we can put multiple layers of genome functions together, right? So here we can draw the histogram firstly, and then put the density plot after the histogram. We use plus to connect them. So we will have a histogram and density plot as well on one plot. Similarly, we can draw the scatter plot first, and then draw the linear trend between these two variables. Or we can draw the Wildling plot, show the density of the winning rate in each season, and then draw the box plot to show the summary statistics of each season. And that means that picture can combine the information of the two pictures, right? That's why the ggplot2 can add a lot of information to one figure, because we can just put multiple genome layers together. But one thing we need to be careful is that the order of genome function is important. For example, the box we can see here the Wildling plot is larger than the box plot. So the first genome layer will be put at the bottom, and the last genome layer will be put at the top. So if we draw the box plot first, then we draw the Wildling plot, but the Wildling plot is larger than the box plot. So the Wildling plot will block the box plot, and we couldn't see the box plot. So actually, the order of the genome function really matters. Just be careful when you design your own figures. And facet, as I mentioned, this is a very important feature of ggplot2. The facet function can help you make panel plot very easily. There are two functions. One is facet wrap. So when you want to split your data based on one variable, you use facet wrap. For example, here we want to we know this plot before, which is this one. Okay, this is for the whole data set, but we want to compare the different seasons. Then we can specify facet wrap to the season, just like this. And then it will give us a scatter plot with linear trend in different seasons. You can also specify any row and column to control how many rows, how many columns do you want. And if you have two variables, for example, we want to split the data to different seasons for a different region, then we need to use facet grid. Same plot plus facet grid, and we specify the row variable first, and then the column variable. So you can see the row variable is east and west, so it's region, and the column variable is different season. And if you do like this, it will give you a linear trend with scatter plot for each season and each region. Okay, so this is one important function of ggplot2, the facet function. Okay, then is the scale. As I mentioned, the scale function is control how we can map the data values to the visual values of an aesthetic. So we can see there's some examples of the scale functions, and the format of the scale function is always like scale, underline element 1, underline element 2. And the element 1 here is always corresponds with an aesthetic mappings in the genome function. For example, x means this scale function control the x-axis. Y means the scale function control the y-axis. Color is just control the color. Field control the inside color of some symbol. And the second element corresponds the characteristics of the static mappings or the variables. For example, continuous here means the variable is a continuous variable. Discrete is a discrete variable. And gradient here, that means you want to change the color gradiently. And manual means you want to change the color inside of something manually. So you can specify what color you want to assign by yourself. Of course, they have different combinations. So it's easy to read. For example, this means the scale function to control the x-axis with continuous variable. Of course, if we change this one to discrete, that means the scale function to control the x-axis with discrete variable. And this one similarly, and this one is scale function to control the color changing in a gradient way. Okay, and that's how we read this scale function. And we can also specify the label of the axis or the legend in the scale function. And the color is a little bit tricky. It's hard to remember all the codes of the color. So I put the color cheat sheet here. And you can see this, you can find the different code of colors here. You can find what color you want to use and put the code into the scale color or the scale field function to control the color. All right, and then let's look at one example. Okay, this is an example. We have 4 static mappings here. We can see x equals to, so we map the offensive rate to x-axis, defensive rate to y-axis, winning rate to color, and region to shape. Okay, so we have 4 aesthetic mappings, and we can generate a scatter plot with color and different shape of the points. And scale, here the scale function control the x-axis with continuous variable. We can rename the label of this x-axis to offensive rate, and limits here means we want to give a limit of the x-axis, so from 97 to 116. And scale controlling the y-axis, and we want to reverse this y-axis. Why we want to reverse? Because as I mentioned, the defensive rate is the lower the better, but we want to put the better team at the top of the figure. So we need to reverse the y-axis. Otherwise, by default, it will draw from 90. The lowest number will at the bottom, and the highest number will at the top. So we want to reverse this y-axis. And scale controlling the color in a gradient way. So we can rename the label of the legend for the color, and we can specify the lowest winning rate we want green color, and the highest winning rate we want red color. So we can see for the team with worst offensive rate and defensive rate, they always have a lower winning rate, so their color is green. And the best team, they have the highest winning rate, so their color is red. So the color of the winning rate change gradiently from the green to red. And we can see a very clear trend is from the left bottom corner is to the right. The color change from green in the left bottom corner to the red in the right upper corner. And scale shape is the different region, right? So we can change the label of the region here. We can, because before is maybe lowercase of the east and west, but we can specify what label we want to give for the shape. Okay, this is an example on how to use the scale function. And then there's still a lot of things in the ggplot too. For example, this coordinate function can control the transformation of the coordinate system, such as the coordinate trans. We can specify we want to transfer y to the square root of y. And we can also change the theme of the plot using the theme function. And the labs can set the title, subtitle, and captions. Theme can customize some like titles, labels, fonts, background, the grid lines on the background, and the legend position, something like that. So we can see the R help for the details. And ggSave can save the plot to your local drive. All right. And I introduced so many things, and it's hard to memorize all the stuff. So the cheat sheet of ggplot2 is pretty useful. We can click this link, and we can see the ggplot cheat sheet. You can see different types of plots. You just find what plot you want to draw, and then check the code. What's the GM function? I'm sorry. What's the GM function, and what's the key aesthetic mappings in the GM function? And here, for example, they can also give different themes. You can see how the theme function changed the background of the ggplot. So this R cheat sheet is very helpful. And R help, as I mentioned, is also a great resource. You can check the details of each function. And there are also a lot of the examples. This is why I like the ggplot2. They have a lot of documents for you to check, and they're all online and all free. So for example, this one, you can see different examples of ggplot. For example, you want to draw the scatter plot, you just go to the scatter plot and see one example to see how they draw the plot, and you can just use the code to write a similar code as their examples. Their examples are pretty fancy, like this. This is a book for the ggplot2, but normally we don't need it because the online resources are pretty enough. As I mentioned, I will leave 5 minutes for the Q&A, so we may not have enough time to go through the case study, but I put the code here. You can see how to draw this picture. It's also available in the practice code. You can see all this kind of ggplot code in the practice 2020 R file. So then I will introduce some useful packages and extensions for the ggplot2. I will not go through it in details because I think I don't have enough time. Just look at this link. So this link is they show what extension available for a ggplot. So for example, ggAnimate, I will also show this one. ggThemes and different fancy plots. You can just find the packages you are interested in, and then download the package and draw the plot and check the example in each extension. So I will just introduce several useful extension. For example, ggalley is very good package to generate EDA, exploratory data analysis plot. It can show the scatter plot, the density plot, and correlation together, and in an easy way, just one line of code. Similarly for the heat map. And ggExtra, they can combine the marginal density versus the scatter plot. Scatter plot, we need two variables to draw the scatter plot, but this ggExtra, ggmarginal can also show the density plot for each variable, and you can also split it to different regions like east and west. ggAnimate is a fancy package, so you can draw the animation. You can draw like a dynamic plot to show the trend, how it changed over time. For example, here this is change over time. This 2017 to 2018, 2018 to 2019, and then go back to 2015 to 2016. For example, we can see this is the Golden State Warrior, how their offense and defense performance change over time, and also their winning rate change over time. Or the Philadelphia, we know Philadelphia got Embiid. After they got Embiid, their winning rate increased a lot. So that's why we can see this Philadelphia change a lot in the 4 seasons. So this is the ggAnimate, and I also put the code in the slides and the practice 2020 R code. So this is all the contents in my slides. As I promised, I will leave 5 minutes for the Q&A. Now it's 2:45. So if you have any questions, you can put in the chat, because there are too many people. Maybe you can put in the chat and I can answer the questions. Thank you. Or if there's no, okay, how hard is ggAnimate to use? Well, it's harder than the ggplot. If you look at the code in the slides, it's much longer than the ggplot code, and you need to specify how it changed over time. But the link of the gg extension, the extension of the ggplot, they give a very detailed instruction of the gg animation. So you can check the detail and draw the plot by yourself. Is the ggAnimate only used for time seasonal changes? What other things could you use it for? Well, it's a good question. So as I remember, you can set what do you want to how to say, like, change it based what variable. So of course you can set the time or season here, but you can also set any variable. It can be continuous variable or categorical variable. It's pretty flexible. So for example, you want to see, let's say, how the winning rate for one team change over offensive rating. So you can generate data set with one team's offensive rate and winning rate in the last 10 seasons. And you can set this one as the offensive rate, and you can see how the winning rate change in different offensive rate. So it's pretty flexible. You can do whatever you want, actually, for the ggAnimate. Yeah, no problem. Yeah, is there any other questions? Because I think our participants is leaving. So if you have question, other talk, you can also unmute yourself to talk, to ask directly. Does ggAnimate only work with HTML documents? Yeah, this is a good question. So I didn't try it in the LaTeX actually. Probably only available in HTML, because I think LaTeX doesn't allow this kind of animation in the PDF file. So probably only HTML documents. But you can also draw it in R. I don't know if can generate some GIF files. I didn't try it before, but I think it can be saved. Save this animation in some other format of the documents, like the GIF. But you can also put it in the HTML documents. Yeah. Any other questions? Yeah, thank you all for coming to my workshop. I'm very happy for you to come. And if you have more questions, I will stay there for longer time. So if you have any other questions, please just feel free to ask. but I know the time is out. You also need to attend the next session. So also please feel free to leave the workshop. I will just stay here for maybe 5 to 10 minutes. Thank you. Okay, are there any other resources you could recommend for learning about ggplot? Well, yeah, actually there are a lot of resources, and I already show a lot in the slides. And for others, to be honest, I didn't use some other resource. I think it's pretty enough for all the use of ggplot in your data analysis. But if you just search ggplot, you really can see there are a lot of documents online, and there are also a lot of tutorials actually, and also a lot of like YouTube videos. So just search ggplot too, then you can see a lot of things. Yeah, so that's one good point, one good thing for a ggplot too, because there are a lot of documents, and I think there is also a forum for people to answer the questions of ggplot too. So you can get a lot of help from the online documents. Yeah, from my experience, the most useful one is the ggplot cheat sheet, because it's really hard to remember all the things. So I always have a ggplot cheat sheet when I draw the pictures. So that is pretty useful. Yeah, if you have further questions, you can just feel free to unmute yourself and ask. Okay, if there is no questions, then I will end this session. And hope you enjoy the workshop today and enjoy the UC SES Symposium today. Thank you. Bye.